So now we've taken a look at a few different methods for creating and running assembly language and machine code programs on our Aquarius computer. Now I'm going to show you probably the most elaborate, but I think so far maybe the best method that I've come up with for creating assembly language programs and running them as machine code on our Aquarius. And there are a few different steps to this, but now we've already looked at all the technical information regarding the memory maps and the ROM disassembly and all that stuff. So understanding this development environment shouldn't be that difficult, but we're going to go through it step by step and we'll see what you think of it, see if it might be something that's useful for you in creating your own assembly language programs for the Aquarius. And it is actually quite similar to a development environment that I've set up previously for Sinclair Spectrum computers or the ZX Spectrum Next computer. And we're going to go through it right now and take a look. All right, so now let's take a look at what I think is probably my most preferred method at this point so far anyway for developing machine code programs for the Mattel Aquarius. And there are quite a few steps to it, but we're going to go through it one by one slowly, and it should be pretty doable. So let's go ahead and get started here. And we'll go down here to our ultimate USB basic data file method. So that sounds kind of confusing, but we'll get into it. So this method requires, well, in my setup, I'm using, like I said, a Windows PC, and it uses USB Basic, as you can see in the title here. So USB Basic is the version of Basic that comes installed with the micro expander, or in the AquaLite emulator working in micro expander mode, or in the Aquarius MX if it's still available. And so we're going to be using USB Basic, which means we need the micro expander functionality. And it says data file method. So we're going to be creating a file which we're going to be loading into our emulator or our computer. So if you want to follow along with me to set up your own development environment, these are the steps that I did, and we'll start at the top here. So the first step says create a folder structure. So on my computer, I simply set up a bunch of folders to store the different files that I'll need in order to run this development environment for creating machine code programs. And this is the folder structure here that I have set up. So on my C drive, my hard drive, which is indicated as C, I set up a folder called Aquarius. And then underneath that folder, I've installed a few different other folders. So here I have a folder called AquaLite 133, which is where I've installed my AquaLite emulator version 1.33. And then also under the Aquarius folder is another folder called TASM 32. Now this is the assembler that I'm using to assemble my program. This is the TASM assembler version 3.2, and I've installed it in a folder called TASM 32. I also have another folder called projects, which is under my Aquarius folder as well. And so this is where I'm going to be storing my project files. And underneath this project folder, I have my individual project files. So I might have a project called project 1, another one called project 2, another one called project 3. In actuality, I'd probably call these files or these folders with names of the actual projects. Like if I was making a breakout game, I might call, instead of calling it project 1, I might call it breakout or whatever. So I have individual folders for the different projects, and then underneath the individual folders for those projects, that is where I'm storing my assembly language program that we'll be creating. And you can see that indicated here, project1.asm, project2.asm. So these red labels here are file names. And you can see up here under the TASM32 folder, there's another file called assemble.bat, which we'll take a look at a bit later. So that's the first thing I did, was set up these folders on my computer, and we can take a look at them now just to see. So I'll go to my Explorer right here, and you can see if I go to my Aquarius folder right here, then according to my instructions, I should have an AquaLite folder, a TASM folder, and a projects folder. And here they are right here. I have AquaLite folder right here, TASM folder right here, and a projects folder right here. And then underneath those folders, I have my different files. For example, underneath projects, I have all these different projects that I have folders for. Here's one called Dungeon for my Dungeon Quest game that I made. And so this is how I've set up my folder structure, like this. And if you want, you can set it up like this, or of course you can set it up however you like, but this is the way that I did mine. So that's the first step, is setting up a folder structure. Now let's go on to step number 2, which says install Microsoft OneNote. So you don't have to install Microsoft OneNote. You don't have to use Microsoft OneNote if you don't want to. As I've mentioned before in my previous game development environment setup videos, I like using Microsoft OneNote, and I've just noted some of the reasons I like it here. So here it says optional but very handy. And point number 1 says lots of room for comments. So when I'm creating my program, I like to use lots of comments. I actually comment every single line in my program, and that's very easy to do when I'm using OneNote, because then all my comments can live in OneNote rather than living in my actual program. So I can have as much or as little comments as I want. It doesn't take up any space in my program, and it doesn't clutter up my program listing in my actual editor. The next point here says room for other notes, tables, pictures, etc. As you can see right here, I'm looking at OneNote right here, and you can set up all kinds of tabs if you want that can have other notes and pictures. So here I have a tab that shows me the memory map, and I have other tabs for the graphics and notes about basic instructions and all kinds of different information I can have on these different tabs in OneNote, which is why I like using OneNote, because I can put all kinds of instructions there and notes for myself in addition to my actual program code. The next note here says easy to structure a modular program. It's very easy to create a modular program in OneNote because you can set up different pages and different tabs and organize it however you want. If I go to my actual game booklet here, Aquarius Games, and let's say I click on Dungeon Quest, you can see I've got all these tabs on the side here where I have all of my different code saved in different pages on this tab. So it's very easy to create a modular program using Microsoft OneNote. And the final note I put here says gives you a backup of the code online. So obviously if I'm typing my program code into Microsoft OneNote, which automatically gets saved in the cloud, then I have a copy of my program saved in the cloud, as well as wherever I happen to save my actual program file. So obviously I'm going to be saving my program file in my project folder here once I create it in my editor, but I'm also going to have it saved in Microsoft OneNote because that's where I type it originally. So I can check off this step here. And now the next note here says install text editor. And this is the text editor you're going to be using for entering your program. It could be Visual Studio Code, which is what I use. It could be Sublime Text. It could be Notepad++, whatever text editor you like to use. And I just have a couple notes here that Z80 ASM extension for syntax highlighting. So in some editors like Visual Studio Code or Sublime Text or other editors as well will allow you to configure extensions which gives you syntax highlighting for your particular type of program. So for example, I'm using Visual Studio Code, which I can show you right here, which as you can see gives me syntax highlighting. It gives me different colors for the different keywords and different colors for the brackets and numbers and so forth. So it's very nice to have syntax highlighting just to make it look more visually appealing. Alright, so we'll move that out of the way. And once you have your text editor installed, then we go down to the next step, which says install Emulator. So I'm using an emulator to test my programs, and as we've been seeing in the rest of this video, I'm using the AquaLite emulator. It's very easy to download and install. I'll include a link in the video description. You simply download it and install it, and that one's done. Next is install assembler. So when we create our program in the editor, this is just creating a text file. It's not actually creating an assembly language program, although we can save it with an extension that says .asm, for example, which stands for assembly. It's not actually an assembly language program that we're creating that's assembled into machine code. It's really just a text file. So we need an assembler to assemble that program or convert that program into machine code. So we need to install an assembler of some sort. So in my case, I've installed the TASM assembler, which I'm testing out. It seems to be working well so far just for my initial testing. And I went ahead and installed it in my folder structure here that we took a look at, which I've labeled TASM32. So you need to go ahead and install an assembler to assemble your program. and you just save it in your folder that you've assigned for your assembler, like I've done, and we can check off that step. And installing that is quite easy as well. There's not really much configuration to that. You just download it and save it in the folder you like. And here is where we do our configuration kind of now, which is in the next step, which says create a batch file to assemble the code. So how this works is, that I'm sure probably many of you know this already, is when we create our program in our text editor and we install our assembler, which will create a machine code version of that text file. We're creating a machine code program out of the assembly language program that we entered into our text editor. We need to actually have some way of executing that assembly process to make it work, right? So we need to create a batch file to tell the computer to have our assembler convert our text file into a machine code program. And it's very easy to create a batch file, and this is how I've done it. So I can do it for you here live. A batch file is simply a text file saved with a .bat extension. It contains instructions that we want the computer to carry out, and in this case obviously we want the computer to carry out an instruction which will assemble our program. So I'm going to create a batch file for you now. So here I'm just going to open a notepad window here. This is just simply Microsoft Notepad, and I'm going to enter an instruction here that I want the computer to carry out, which will assemble my program. And here I've listed the instruction that I'm going to put in my batch file. And here is the instruction right here, TASM -80 blah blah blah. And I'm just going to copy all this line here, copy, and paste it into my notepad right here. So here is my batch file that I'm going to save by going to File, Save As. And this batch file, I want to save it in the same folder where I installed my assembler, because the assembler is what's going to be executed by this batch file. So I'm going to just, well actually I'm already in my assembler folder. You can see here I'm on the C drive, Aquarius folder, and then I'm in my TASM32 folder, which is where I've installed the assembler, and I'm going to save it. And you can save it as whatever name you like. I guess I'll save it as build. So if I call this one build, and it's not case sensitive of course, and remember I have to save it with a .bat extension, which stands for batch. So build.bat, and click save. So now you can see here it's called build.bat, and that's my batch file. And of course we're going to go through the instruction that I've just put into this batch file to see what it does. But first let's go back to my checklist here, and we'll take a look at the notes I put here. It says source file is in project folder, and then it says output file is in Emulator USB folder, and save the batch file in the assembler folder. So we've already saved our batch file in our assembler folder, right? And now let's take a look at this instruction so we can see what these other two notes mean. The first part of this instruction says TASM. That simply means it's going to execute or invoke the TASM assembler. And here we have some options. This first option says -80, which if you look in the instruction readme sheet for this assembler, this tells the assembler that it's going to be assembling a Z80 program, which is what we want because obviously we're creating a Z80 assembly language program. And then the next option here says -B, which means it's going to make a binary file, which is what we want because the binary file is our machine code program. And then the entire rest of this instruction simply tells it what source file to use and what destination file or output file to create. So our source file is of course going to be our assembly language program that we're making in our text editor, and this will be located in whatever folder that you've set up depending on your folder structure. So in my case it's going to be saved here under the C drive, and then inside an Aquarius folder, and then underneath that there's a projects folder. Then underneath that, remember I had the project 1 and project 2 folders. Well, in this case I've called my project MC Test. So I have an MC Test folder, which is my project folder, and then underneath that there's a file called mcprog.txt. So this you might want to change. So for example, let's say instead of .txt, even though we're creating a text file in our text editor, I could also save this as a .asm file if I want. So why don't I change this to .asm, and then this batch file will look for a source program called mcprog.asm, which stands for machine code program. So that's the file that it's going to assemble into a machine code program, and here is the output file that it's going to create and where it's going to put it. So it's going to create a machine code binary output file, and it's going to save it here on the C drive, under the Aquarius folder, under the AquaLite 133 folder, which is where I have the emulator installed. And then of course it needs to be in the USB file underneath that emulator folder, because the emulator looks in the USB folder to find the programs that it's going to be running. And then the name of my program is going to be called mcprog with no extension. So my emulator is going to be able to run the machine code program called mcprog, which was created from my initial text file that I'm going to be saving as mcprog.asm. So that's what this batch file does. All you need to do is copy this line of text into the notepad, save it as a batch file, and then when we run it by double clicking on it, it should create this output program for us called mcprog and put it into the USB folder. So we can save this file and move this window, and now this step is completed. Create a batch file. Done. Alright, so now we get on to the actual program creation, which is in our next step here. Create the program in OneNote. So as I mentioned, you don't have to use OneNote if you don't want to. I like to, so I'm going to show you how I do it. And here the notes say type the assembly program into OneNote, and it says indent the code, put labels at the left column, follow assembler syntax rules. So depending which assembler you're using, it could be TASM, it could be some other assembler if you like. Those assemblers have their own rules for syntax and how the program actually needs to be laid out. For example, TASM assembler likes to have the labels in the very leftmost column, and then if you indent the code, then it's not considered a label. So you need to follow whatever rules your particular assembler uses. So in my case, I'm using the TASM assembler, and so I'm going to create my program in OneNote. So let's go to my program in OneNote. Here, so I'm just going to copy this program, Control C, and paste it over here, Control V. Zoom in a bit so we can see what we're looking at here. Alright, so here's our program, and I'll just put some notes here. Alright, so the first line of our program, it calls a ROM routine, which allows us to pass value into the DE register pair. I'll say for passing value into DE register pair. And then the second line here says load HL, comma 12288, assign address to HL register pair. Then the next line loads a value into the HL address, and this value is going to be the value that we passed to it. Remember, in the USR parameter brackets, and so we're going to be passing it a value, and it's going to end up in the E register. So we're going to load a value from E register into the address pointed to by the HL register pair. So load value from E register into address pointed to by HL. So HL is going to be pointing to this 12288 address, which is the hidden row at the top, which is going to fill our border with a character which has a value that's in the E register. And then our last line here is simply a return statement, just like that. So we'll go back to our checklist, the step that says create the program in OneNote. And now the next step says copy the code to the editor. Save the program with source file name indicated in batch file. So let's go ahead and open the editor, which in my case is Visual Studio Code, as you can see here. So I'm just going to select File, New Text File. Then it says select a language, so I'll click on that. And since I've already installed the Z80 extension for giving me highlighting for Z80 assembly language, I'm going to type Z80. And here it found our extension here, Z80 Assembly, so I'll go ahead and click on that. And now it's expecting an assembly language program. And if I go and copy my program from OneNote right here, Control C to copy this, and then Control V. So here's my program now pasted into my editor. And I may need to do some alignment based on the syntax requirements for my particular assembler. For example, I might need to indent these so they're not considered labels. So I could indent these if I need to. Just follow whatever rules your particular assembler uses. So here is my assembly language program now pasted into my Visual Studio Code editor. And we'll go back to my checklist. And here it says save the program with source file name indicated in batch file. So remember our batch file here, our source file name that I used was mcprog.asm. And remember, I'm saving mine in the folder mctest, which is under my projects folder. So I just need to make sure that I save my program or my file in the correct folder, which in my case is going to be under the mctest folder, which is under projects, which is under Aquarius. So back to my editor. Here we go. So now I need to save this file into the correct folder. And what I'm going to do in Visual Studio Code here is I'm going to go to File, Open Folder, and then just look for that folder. And so in my case, it's under Aquarius. And again, it depends however you set up your folder structure. This is how I've set up my folder structure. So I have Aquarius, Projects, mctest. So this is where I'm going to be saving my file. And I'll choose select folder. So actually, I guess you need to select the folder before you paste your program into the editor. So I'll just do this again. File, new text file, select the language, Z80 Assembly, and then I'll go get my program again. Right here. And now I want to save this. I'm just going to indent this. I'm pretty sure the assembler wants me to indent this, so I'm going to indent it. And now I need to save it as mcprog.asm under the mctest folder. So I'm going to save it, File, Save As. And here I am under the mctest folder, so I'll call it mcprog. And again, the case doesn't matter, it doesn't have to be capitalized or anything. mcprog.asm. All right, so there is my file now. It's called mcprog.asm. Now I'll go back to my checklist, and I can check off this step, copy the code to the editor. Now the next step, which is the fun step, assemble the program. And how do we do that? It says run the batch file to create a machine code file from the source file. So if you've set up your batch file correctly and it is located in the assembler folder and it points to the correct source file and the correct output file location, which should be the USB folder under the emulator installation folder, then when we run this batch file, it should create for us this output program called mcprog, or whatever you want to call your program, and this will be the resulting binary machine code program that our emulator can run, or our actual Aquarius computer could run. So let's go ahead and execute this batch file now, and let me find it in my Explorer, which should be in my assembler folder, Aquarius TASM 32, and here it is right here, build.bat. Remember, I saved it as build.bat. So if I click on this now, it should create that mcprog output file in my USB folder. So let me click on it here, and you see that black window briefly appeared. Now let me go take a look at my USB folder, which should be here under Aquarius, AquaLite 133, USB, and There it is right here, mcprog. So this is the output file I just created, and this will be the machine code program that our emulator can now run. Or if you copy this file onto a USB stick, then your actual Aquarius computer with micro expander module installed should be able to run it as well. So let's go back to the checklist and check this off, assemble the program. And now the next step here says load the machine code program into the emulator. So of course the emulator needs to have this program loaded in order to run it. And let's just read the notes here. It says enable micro expander mode in AquaLite emulator, just like we did before. So let's go ahead and do that. And I'm going to go into tools, options, peripherals, and enable the micro expander mode and click OK. And you see the boot screen for the micro expander comes up. And now the next step, it says load mcprog, address. So if I go back to the emulator and I press enter and I type load and then in quotes mcprog end quote, because remember there's no extension on this output file, and then address. So now what address do I want to type here? So again, I'll just use the same address I've been using all along, which is 16,000. And again, you could change this address now wherever you feel is suitable. So if we go back and take a look at the memory map, for example, right here, remember this diagram? So if I zoom in here, we took a close look earlier at this memory space right here from 0000 hexadecimal to 4000 hexadecimal, or 3FFF hexadecimal, which is one less than 4000. So this is the lower 16K of RAM, and remember we determined that we had this user RAM section 2K available to us, and that's where our 16,000 decimal address lives, in this 2K section. But let's take a bit more detailed look at this memory map layout to see how the rest of the memory is being used, because remember now, since we're using that micro expander module or the micro expander functionality, that micro expander has 32K of RAM built into it. So we're no longer limited to that measly 1.7K of RAM down here in this user RAM section. We have 32K of RAM available to us. So let's take a look at the rest of this memory map diagram now. And I want to read the text first and continue where we left off. So remember we discussed about how we were left with 1.7K of free usable RAM, which is in the lower 16K of memory in the computer. Well, let's see what the rest of this text says. It says, with the lower 16K occupied, the Z80 CPU inside the Aquarius can still address an additional 48K of memory. The upper 16K of memory part is reserved for cartridges. So if we look at this memory map, this entire memory map diagram here goes from 0 up to 64K, which is FFFF in hexadecimal. So 0 hexadecimal to FFFF hexadecimal is 64K, 64 kilobytes of memory. And the notes say here that we still have 48K available to us right here, because this lower 16K we just discussed plus 48K equals 64K. And it says here the upper 16K is reserved for cartridges. So up here on this diagram, the upper 16K is right here. You can see from C000 to FFFF, it says that's reserved for cartridges. So we probably don't want to put our machine code up there. It says in the figure on the left, this memory area is located on the top from C000 to FFFF, which we just took a look at, C000 to FFFF. So if we take a look at this diagram one last time here, we can see that if this top area above C000 is reserved for cartridges, and the space we looked at before ends just below 4000, then this entire space from 4000 hexadecimal up to C000, or one below that, which would be BFFF, this entire section is available for us to put our machine code programs. So we could load our machine code program anywhere in this entire section, and it should be able to operate using the micro expander module, which gives us this 32K of RAM. So let's convert one of these addresses to decimal. Let's say we want to store our program here at 8,000 hexadecimal. So we'll open our calculator and I'll enter 8,000 hexadecimal, which equals a decimal value of 32768. So just to round it off to make it easy to remember, why don't we give it an address of 33,000. So back in our emulator here, instead of using 16,000, why don't we load it this time into address 33,000? Because we know we have that 32K of memory available to us in the micro expander, so let's go ahead and use it. And now I'll press enter. So it didn't actually like that 33,000 address. This should be a chunk of 32K of RAM right here. So this would be 4 plus 2 plus 1 plus 1. This is 8K, and there's 16K here. This is 24K. So I would have thought that the address at 8,000 hexadecimal should be available to me. But I guess it's not for some reason. So let me try a lower address here. Let me load it into load MC prog. I'll load it into address 25,000 or maybe 30,000. That seems to work. So I'll load it at 30,000 for now, and we'll go back to my checklist. So load the machine code program into the emulator, which I've done using this instruction here, load MC prog, comma, address. It says load address should match the org of the assembly program unless code is relocatable. So this is what we discussed earlier. If your program is not relocatable, if it has jumps to specific addresses, then you'll need to make sure you load your program into the correct memory location for those addresses to work. My program is relocatable since it doesn't have any jumps, so I should be okay. And I can check off this step now. And then the final step says run the machine code program. And again, we're going to do this using the same basic program we used before. You can see here there's a clear statement. Since we're using the micro expander functionality, it gives us some extra basic commands, including this CLS command as well as the load command. So the CLS command clears the screen. So line 100 here simply clears the screen, and there's an input to input the machine code starting address, just like we did before. And then we have this load instruction. Oh, I actually didn't need to load the program manually up here because my program is doing it for me. And that's what it does here in line 110. It loads our machine code program to this address in memory. And then again, it breaks down that address into its high and low bytes, and it pokes those high and low bytes into the system variable for the USR subroutine or function to use to run our machine code program. And then at line 160 here, we have an input to input the value to pass to the machine code routine. So again, we're going to pass a value to the machine code routine, or this USR routine, that will be passed in the DE register pair that our assembly language program will use to set that border character. And then our next line simply says press a key to run machine code, and then it waits for a key press, and then it executes this USR routine, passing to it this value stored in the V variable that was set during this input command right here. We input a value into the V variable, which gets now passed to this USR subroutine, and that's going to be used in our assembly language program. So let's go ahead and copy this code by pressing Control C, and we'll go back to our emulator here. And remember, we're in micro expander mode. So if I do File, Soft Reset, you can see it boots up in the micro expander boot menu, and I'll press enter to go into USB Basic. Now I'll press Control V to paste my basic program in. And sometimes the emulator can be a bit touchy, it seems like. It doesn't allow me to paste it in right now, so I'm just going to reboot it and see if that helps. Okay, there, now it's letting me paste in my program. So now if I run it, it asks me for machine code starting address, and let's use 30,000. And value to pass to machine code routine. Let's choose a different character this time. Let's go back to our user manual for the Aquarius. right here. And what's an interesting character we can poke into the border or load into the border? How about this splotchy thing here, code number 209. Back to our emulator, and I'll enter 209 and press enter, press a key to run machine code. And there, now we have our border filled with this splotchy character. So this, I think, is probably the method I'm going to be using, the development environment that I'll be using to create my machine code programs, unless I come across a better method. But this one seems pretty straightforward to me. All we need to do is create a program in our text editor, use our batch file to convert that to a machine code program, which automatically gets saved in our USB folder for our emulator, or you can save it onto a real USB flash drive if you like, to run on real hardware. And then we can execute that machine code program using this basic program, which in this case passes a value into the USR subroutine that we're using to change the border. So even though this one might be a little bit more involved to set up, actually using it to create a program is pretty straightforward. So there we go. We've taken a look at 4 different methods for creating and running Z80 assembly language and machine code programs on the Aquarius computer, and you can try them out if you like, see which one you like. And of course, this is just the beginning of my machine code programming journey on the Aquarius, and I'm hoping that I'm going to learn all sorts of new techniques and tricks that I can use for creating some machine code routines to use in my own games for the Mattel Aquarius. So as always, thanks for watching. Hopefully you found this video informative and interesting. And if you'd like to support more projects and videos and games, then feel free to head over to my Patreon site and check it out and subscribe if you like. And we'll see you next time.